Morning, everybody. Today we are going to talk about angles and their measures. So before we talk about an angle, we're going to talk about what a ray is. So this should be a review from geometry. A ray is the portion of a line that starts at an initial point and passes through another point and continues on forever in the same direction. It's just like a ray of sunlight. So here is a ray, a picture of a ray. It has an initial point right here. This is the initial point. It's where it starts. This would be like the sun. It's where the light starts. And it goes off in a direction. It passes through point B. And it goes on forever in that direction. Okay? And when we write it like this. This is read as ray AB. You always start with the initial point, and the arrow always goes to the right. Even if the picture were to look something like this. I had this right here. Okay, I would write that as ray DC, with the arrow going to the right. Okay, and keep in mind ray AB and ray BA are two entirely different things. Ray BA starts here, goes that way. Okay, an angle. An angle is formed by two rays that have the same initial point. So an angle has an initial side and a terminal side. All right, the initial side is where it starts, the terminal side is where it ends. An angle with a counterclockwise rotation is considered positive. So this would be a positive angle right here. Goes counterclockwise, initial side here, terminal side here. The arrows show you the direction. Okay, and then an angle with a clockwise rotation like this one started here, went all the way around to here, that's considered a negative angle. An angle is in standard position if the vertex is located on the origin and its initial side lies on the positive x-axis. So this one is written in standard form because the vertex is right here on the origin, 0, 0. Here's the initial side. So the angle goes like this. This would be the terminal side over here, which is where the angle ends. Okay, so a degree is 1/360th of a rotation. So a rotation is a complete turn. And if I divide that into 360 pieces, each one of those pieces is called a degree. Degrees are divided up into minutes and seconds. So 1 minute is a 60th of a degree, and 1 second is a 60th of a minute. Okay, so there's 3,600 seconds in a degree. Okay, so the first thing we're going to do here is convert 50 degrees, 6 minutes, 21 seconds to a decimal in degrees. Pretty easy to do. So it's going to be 50 plus, this is part of a degree, so this is 6/60ths of a degree, so we're going to add 6 out of 60. And that's 3600ths, so that's 21 out of 3600. We're just going to type it just like that into our handy-dandy TI-84 plus C Silver Edition graphing calculator. So 50 plus open parentheses 6 divided by 60, close the parentheses, plus open parentheses 21 divided by 3600, close the parentheses. Bam! This is 50.10583 repeating degrees. Okay, now what I would like you to do is, I would like you to convert 29 degrees, 42 minutes, 65 seconds to a decimal in degrees. So go ahead and pause the video right now, take a look at this problem, and jump back on here, and we'll see if you got the right answer. Okay, so here we go. This is going to be This is going to be 29 plus 42 out of 60 plus 65 out of 3,600, which I'm going to do in my calculator so I make sure I don't make any careless arithmetic errors. I'm going to type it just like that. And so I get 29.71805 repeating degrees. Pretty simple. Okay, next we have to go backwards. So we're going to convert 21.256 degrees to degrees, minutes, seconds form. That's what this stands for, degrees, minutes, seconds. Okay, so the 21 degrees, obviously, that's easy. I just got to deal with this part right here, which is a fraction of a degree. So I'm going to take 0.256. I'm going to multiply that by 60 because there's 60 minutes in a degree. So 0.256 times 60, that comes out to be 15.36. So this is minutes and a fraction of a minute. Okay, so it's going to be 15 minutes. Now I've got to figure out how much this is, 0.36. Now this is a fraction of a minute, and there is 60 seconds in a minute, so I'm going to multiply by 60 again. 0.36 times 60, 21.6. And that's in seconds, so this is 21.6 seconds. And there's my answer. So why don't we have you pause the video here and convert 142 degrees, 142.681 degrees to degrees, minutes, seconds form. So let you pause the video here and then jump back on here and compare your answer. Okay, so the degrees shouldn't be a problem. It's 142 degrees. 0.681 times 60. That's going to be 40.86 minutes. So I'm going to have 40 minutes here, and then 0.86 times another 60 comes out to be 51.6, and that's in seconds. That's as far as we're going to go right there. So hopefully you got that. Okay, a central angle, another term from geometry. A central angle is formed when the vertex of an angle is located at the center of a circle. Okay, so if this is the center right here, C, this is the central angle, okay? And the nice part about central angles is their measure. So this appears to be a 90-degree angle right here. Their angle is exactly the same as the measure of this arc right here. So if that's 90 degrees, this is also 90 degrees right there. And that works every time. So this central angle over here would be 270 degrees, which means this arc over here would also be 270 degrees. All right, this is important because you probably always measured in degrees up to this point, and we're going to do most of our work in radians, okay? A radian is formed when the radius of a circle is equal to the length of the intercepted arc formed by the central angle. So what that means is, if this is the center right here, C, okay, when this length right here is equal to this distance around here to here, then this angle is 1 radian. Okay? And here's the thing. Keep this in mind. One complete turn like this, that is one complete turn is equal to 2 pi radians. 6.28 approximately radians. Okay? All right, now you should have one of these in Google Classroom. This is it's just a circle here, and we're going to put some information on the circle with regards to angle of radians, okay? So, as I said, there's 2 pi radians. So, this would be 0 radians. Okay, and this would be, well, let's do this in degrees first. Okay, if that's 0 degrees, then this would be 180 degrees. This would be half of this would be 90 degrees. And this down here would be 270 degrees. This right here would be half of 90 degrees, or 45 degrees. This would be 45 degrees from here, so this would be 135. Another 45 would be right here, this would be 225. Another 45 to this would be, this one would be 315 degrees. Now you'll notice this quadrant right here is divided into thirds by this and this, so this would be 90 divided by 3 would be 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and when I get back here, this is also 360 degrees. Okay, if I do this in radians, we said this was 0 radians, and that a complete turn, if I go all the way around, would be 2 pi radians. Which means since this is half of that, this would be pi radians. This right here would be pi over 2 radians, half a pi. This would be 1.5 pi's, or 3 pi over 2. Okay, then this would be half of this, obviously, so pi over 2 divided by 2 would be pi over 4. So these I'm going to be counting by pi over 4, so 0, pi over 4, pi over 2, that's 2 pi over 4. This would be 3 pi over 4. This would be 4 pi over 4, which is just pi. This would be 5 pi over 4. 6 pi over 4, which reduces to 3 halves. 7 pi over 4. 8 pi over 4, which reduces to 2 pi. Okay, now what about these? Well, remember this is a third of this one. So a third of half of a pi is a sixth of a pi. This is pi over 6. This is 2 pi over 6, which would be pi over 3. 3 pi over 6, which is half of a pi. 4 pi over 6, which is 2 pi over 3. This would be 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6 would be 4 pi over 3, 9 pi over 6, 10 pi over 6, that would be 5 pi over 3. This would be 11 pi over 6, and this would be 12 pi over 6, which is 2 pi. Okay, so you can convert from this unit circle here between radians and degrees for certain angles. Okay, a radian is a measure of an angle just like degrees, where the central angle is 1 radian when the arc length is equal to the radius. So we talked about that a little bit. You know, if this is x and this is x, then this is 1. Okay, and now if you don't see a degree sign there, that means that it's probably in radians. 1 revolution is equal to 2 pi radians. You need to know that. Therefore, a half a revolution is pi radians. And, okay, so now if we want to convert between radians and degrees, we know that pi radians and 180 degrees are the same. We know that from this It's from this unit circle right here. Pi radians and 180 degrees are the same thing. So we can convert using these, okay, using that formula. So if we want to convert 60 degrees to radians, here's what we're going to do. We're going to take 60, we're going to multiply that by pi over 180, because basically pi over 180 is essentially equal to 1. So this would be 60 pi over 180, which would be pi over 3 radians. And if we go back and we look at our chart back here, pi over 3 is 60 degrees. Okay? All right, convert 2 pi radians to degrees. Okay, so here's the thing. This one's going backwards. So in this one, since we were in degrees, we put pi's into this thing. Okay? So the pi's went on top. And this one, we want to take the pi's out. So the pi's going to go on the bottom. So we're going to take 2 pi over 5. We're going to multiply that by 180 over pi. Okay, that's going to cancel out the pi's. Okay, this is going to be 360 over 5, which comes out to be 72 degrees. Now, just because a number doesn't have a pi in it does not mean that it's not in radians. So I could have 2 radians, and I could convert that into degrees. I would do it the same way. So it would be 2 times 180 over pi, which would be 360 over pi, which I'd probably want to get my calculator out and figure that out. 360 divided by, make sure you use your pi key, by the way. That'd be about 114.59 degrees. Okay. All right, arc length can be calculated using this formula right here. S equals R times theta. Okay, so S is the arc length. Now keep in mind there's a difference between arc length and arc measure. Let's take a look at that real quick. So let's say I have something like this. Okay, the arc measure is how many degrees or how many radians I have to turn from here to here to include that angle. Okay, so an arc measure is going to be in either degrees or radians. An arc length is how far would you have to walk if you started here and you walked around this circle to that point right there. That's S. R is the radian, or is the, R is the radius, and theta is the angle right there in radians. Okay? So, let's see. I don't have an example here. Let's have an example. Here's a circle. All right, we'll say this is we'll say it's 2 pi over 5 radians. Find S. Oh, we need to know the radius. Let's say that the radius here is 12. Okay, so then S would equal the radius, which would be 12, times theta, which would be 2 pi over 5. Okay, so we get out our calculator. Oh, and let's say that this is in feet. Okay, so that'd be 12 times 2 pi divided by 5. So this would come out to be 15.08 feet. All right. Area formula for a sector. So a sector looks like this. It's like a piece of pie. Okay, and the area formula is A equals 1/2 the radius squared times theta. And again, this is the central angle in radians. So if we were going to find the area of this sector right here, our area would be 1/2 times the radius, which is 8 meters, squared, times theta, and theta is 1/2 a radian. So let's see, 1/2 of 1/2 would be 1/4, and that's 64. 1/4 of 64 would be 16. So the area would be 16 square meters. And that's pretty easy to do. Okay, next, find the arc length of this sector. So the arc length would be S equals theta R. Okay, so S would equal 1/2 times the radius, which is 8, so that would be just 4 meters. Piece of cake. And that's that. So here we have your assignment. There is 24 problems. Okay, make sure you do a good job and show all your work. And I'll have a nice picture of this in Google Classroom for you. And you're off and running. I'll see you next time.